Hello my dear students. So I have been discussing extra questions on changes of matter. So in the previous chapter also I discussed some extra questions with you all, and in this chapter I am going to continue with the extra questions. Extra question 50. Balance the chemical equations given below using the inspection method. So you're familiar with the inspection method, students. You need to look at the reactants and products, looking at the atoms of each element present. You just count them and accordingly you balance them. So that is the inspection method. First one, Ag2O is silver oxide, gives rise to Ag silver and O2 oxygen gas. If we are to balance that, I will rewrite and balance again. Ag2O gives rise to silver and O2. Here you can see two silver atoms, one silver atom, one oxygen atom, two oxygen atoms. So we will balance oxygen first. So here I will put 2 so that to balance the oxygen atom. That's balanced. But now silver, there are 2 into 2, 4 silver atoms. So we need to put a coefficient 4 in front of silver. So I didn't tell you all this before the start of the question, students. I always tell you to answer the questions first. So even if you haven't answered, you all balance them first and then you can check with my answer. That will be more better for you. You will learn more. So then the second one, magnesium hydrochloric acid, magnesium chloride and hydrogen. So if we are to balance that, Mg plus HCl gives rise to MgCl2 plus H2. So here you can see one magnesium, one hydrogen, two hydrogen atoms there, one chlorine, two chlorine atoms there. So you know the method. We put a coefficient 2 here. Now 2 hydrogens, two chlorines, one magnesium. So it is balanced. Then the next one, KBr, potassium bromide with chlorine gives rise to potassium chloride and bromine. So look at the reaction. KBr plus Cl2 gives rise to KCl plus Br2. Now we have one bromine here, two bromine there, two chlorine here, one chlorine here. So we need to put a 2 in front of KBr. So you get 2 Br2. At the same time, if we put a 2 in front of KCl, 2 potassium, 2 bromine, and 2 chlorine, 2 chlorines. So that is balanced. 2 KBr plus Cl2 gives rise to 2 KCl plus Br2. Then the next one, KClO3. What is that? Potassium chlorate. When it decomposes, it gives rise to potassium chloride and evolves oxygen gas or liberates oxygen gas. Now one potassium, one chlorine, one potassium, one chlorine. But there are 3 oxygen atoms here, 2 oxygen atoms there. So you know what to do. Normally when there is 2 and 3, we go for the least common multiple, 6. Here also we need to have the number of atoms of oxygen as 6. So what can we do? We can put a 2 coefficient in front, 2 into 3, 6. So we put 3O2 there. 3 into 2, 6. Then we need to balance KCl. 2 potassium, 2 chlorines. So easy, coefficient 2 there. So 2 potassium chlorate gives rise to 2 potassium chloride and 3 oxygen molecules. Is that okay? Then the last one, sodium with water gives rise to sodium hydroxide plus H2. Now one sodium. Here you have 2 hydrogens, there you have 3 hydrogens. One oxygen. here you can remember we balance it in a slightly different way. What do we do? To make this hydrogen, we put a 2 here so that hydrogens become 4. So to balance that, we put a 2 here also. And to balance, now you check 2 into 2, 4 hydrogens, 2 plus 2, 4 hydrogens, 2 into oxygen, that is 2 oxygens, here also 2 oxygens. But now sodium has become 2, so we need to put the 2 there. So that is how we balance this equation. Is that clear, students? So 2Ag2O gives rise to 4Ag plus O2. Then Mg plus 2HCl gives rise to MgCl2 and H2. 2KBr plus Cl2 gives rise to 2KCl plus Br2. 2KClO3 gives rise to 2KCl plus 3O2. And 2Na plus 2H2O gives rise to 2NaOH and 1 H2 molecule. So I am sure you all also balance these equations correctly. With that, we will move on to the next question. Extra question 16. Answer the questions related to the list of metals given below. So there is a list of metals: iron, zinc, sodium, gold, potassium, platinum. Shall we recall the activity series once again, students? You can remember potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, then we have hydrogen, then after that we have copper, mercury, silver, platinum and gold. Look at the metals that are given to you. Iron is given to us, zinc is given to us, then there is sodium, then there is gold, there is potassium and platinum. The first two elements, highly reactive, moderately reactive zinc and iron, and platinum and gold, the least reactive elements. So you know the reactivity of these elements because you know the order of the activity series, the metals in the activity series. The reactivity decreases as you go down the activity series. So then, if we look at the questions, arrange the metals in order of the activity series. So since we have written it down already, it's easy. Potassium, then you have sodium, then you have zinc, iron, then platinum and gold. So potassium, sodium, zinc, iron, platinum, gold in order of activity series. Then write the metals extracted by electrolysis. The metals that are highly reactive, they are extracted by electrolysis. What are they? Potassium and sodium. Specify the metals that are extracted by reducing the O with a reductant. Reductant can be a metal or an element. So what are the elements? Moderately reactive elements. We have identified them here. What are those? Zinc and iron. Zinc, iron. Then the fourth one. Identify the native metals from above. What are those? The least reactive metals that are at the bottom of the activity series, usually silver, platinum, gold. Here we have platinum and gold. So it's going to be platinum and gold. So you can see the metals in order of activity series. So potassium, sodium, zinc, iron, platinum, gold. Then we have the metals extracted by electrolysis, potassium and sodium. Then we have the metals that are extracted using a reducing agent, zinc and iron. And here we have the native metals, platinum and gold. So I am sure you can understand all these answers, students. With that, we will move on to the next question. Extra question 17. Answer the questions that are based on the metals given below. A question similar to the previous one, but here the metals are different. magnesium, copper, aluminium, iron and zinc. So since I have already arranged them in the activity series, I will just arrange them in order of activity series. So you can remember magnesium comes first, then you will have aluminium, then we have zinc, then we have iron and we have copper. The 5 metals: magnesium, aluminium, zinc, iron and copper. So here, if we look at the questions. Write 3 metals that evolve gas bubbles fast with dilute hydrochloric acid. Now here students, you can remember if you look at the activity series. Now we said a metal that is above the another metal in the activity series can displace the second metal from the salt solution. So if you take the metal and hydrochloric acid, you can remember before copper there is hydrogen. All these metals are above hydrogen. So that means they are more reactive than hydrogen. They can displace hydrogen from the acid solution. But if you take copper, copper is below hydrogen. So that cannot displace hydrogen from hydrochloric acid. So if you relate this with the reactivity of metals with acids, you can remember all these metals, magnesium, aluminium, zinc, they react fast with dilute hydrochloric acid. Iron reacts slowly with hydrochloric acid. Why? Because iron is just above hydrogen and it is a slow reaction. But copper does not react with dilute hydrochloric acid. Why? Copper is less reactive than hydrogen. Copper is below hydrogen. So therefore, the reaction does not happen. Now can you all understand that? So here, write 3 metals that evolve gas bubbles fast with dilute hydrochloric acid. Magnesium, aluminium and zinc. Magnesium, aluminium and zinc. We don't write iron because iron reacts but slowly. So here the question is bubbles fast with dilute hydrochloric acid. Then write the metal that evolve gas bubbles slowly with dilute hydrochloric acid. So that is going to be iron. Then the next one. Write the metal that does not evolve gas bubbles with dilute hydrochloric acid. That is copper. So now you all can understand all these reactions. The metals that are above hydrogen, they displace hydrogen, single displacement reaction. So the metal reacts with dilute hydrochloric acid to evolve or liberate hydrogen gas. But metals like copper that are below hydrogen are less reactive than hydrogen. Therefore, they do not react with dilute acids and they don't displace hydrogen. Now you can understand that. So with that students, I will move on to the next slide. Answer the questions that are based on the metals given below. The same metals: magnesium, copper, aluminium, iron and zinc. What is the gas evolved in the above observations? What is the gas? It is hydrogen gas. So that is what we discussed so far. Hydrogen gas. You can write it as hydrogen gas or you can say H2 gas. Hydrogen gas. Either answer is correct. Write balanced chemical equations for the instances mentioned above. So we looked at all the reactions. So first one, magnesium with hydrochloric acid, that will give rise to MgCl2 plus H2. So to balance it, we put a 2 there. You can remember that. Then the reaction of aluminium. Aluminium plus HCl gives rise to AlCl3 plus H2. Now here of course 3 chlorine, 2 hydrogen. So to balance that, you need to have 6 molecules, least common multiple. 6 HCl. So to balance that, you put a 2 here and 3 there. Then to balance aluminium, you put 2 here. I'm doing it quickly, students, because you're already familiar with balancing all these equations. You have learned the balanced chemical equations already, so you know them. Then the reaction of zinc with hydrochloric acid. Zn plus HCl, that will give rise to ZnCl2 plus H2. Again, it's easy to balance 2 chlorine, 2 hydrogen, so this has to become 2. Then we have iron with HCl. Iron with HCl, that will give rise to FeCl2 plus H2 gas. So these are all similar. FeCl2, so Cl2 and H2, this has to be 2. So magnesium, zinc and iron, it's easy. You have to have 2 hydrochloric acid molecules. But this one, since the valency of aluminium is 3, you get the aluminium chloride as AlCl3. So the balancing is slightly different. Are these okay, students? We are familiar with all these reactions. So I am sure you were able to understand and write them correctly. With that, I will move on to the next slide. Extra question 18. Gases can be collected in the laboratory by various methods. So can you recall all the methods? In all the activities, we collected the gas using downward displacement of water. Because hydrogen, oxygen and carbon dioxide, they will collect over water because they are all less denser than water. So downward displacement of water. But hydrogen can be collected by downward displacement of air. Why? Hydrogen is the lightest gas. It is less denser than air, so it will collect over air. But carbon dioxide is more denser than air. Because of that, it can be collected by upward displacement of air. So I am sure you can remember all those information. So first question, write a reaction that is used to collect hydrogen gas in the laboratory. So here students, they have said write a reaction. They have not told you to write the balanced equation or to write the chemical equation. So they just want you to say what the reactants are and the reaction would be. So what is the reaction that is used to collect hydrogen gas in the laboratory? Normally a metal reacting with a dilute acid. So metals are usually zinc or magnesium. They can react with dilute hydrochloric acid or dilute sulfuric acid to produce hydrogen gas. So that is what you need to write here. So metals like magnesium or zinc can react with dilute hydrochloric acid or dilute sulfuric acid to evolve H2 gas. So if you write that, that is correct. Or you can even say metals reacting with dilute acids. Then the second question, write balanced chemical equation for the reaction you mentioned above. So here we said magnesium or zinc with hydrochloric acid or dilute sulfuric acid. So I will write 2 reactions just to show you all, just to recall what we have learned. So if it is, let's say, magnesium and sulfuric acid, the products will be magnesium sulfate and H2 gas. It is a balanced chemical equation. Even if this was zinc, this would have become zinc sulfate, but the same equation, similar equation. It will be already balanced. Or else, if you give the acid as, take the acid as hydrochloric acid, let's say with zinc. plus HCl, you will get the products as zinc chloride and H2 gas. So here we put a 2 in front. That also, if this is magnesium, this will become magnesium chloride. So you need to write just one equation, students. Because here we have given all the possible metals, magnesium or zinc, and the two possible acids, hydrochloric acid or sulfuric acid. So here they have asked you to write one chemical equation. So you can write any one of those. You can even change the metals. This can be zinc, this can be magnesium. Accordingly, you have to write the products. So I am sure, students, you all can understand that clearly. So with that, I will move on to the next slide. What is the method used to collect the gas in the above? What is the method used? Normally, you can use downward displacement of water, or you can use downward displacement of air. So here, what is the method used to collect the gas in the above method? Normally, we use downward displacement of water. Displacement of water. And here the next question you can see, write another method used to collect hydrogen gas. So there I will write it as downward displacement of air. Displacement of air. So here both are downward displacement. Why? Because hydrogen is the lightest gas. It is lighter than air, it is lighter than water. So downward displacement of water, downward displacement of air. Is that okay, students? So then we'll move on to the next slide. Extra question 19. Various reactions used to prepare oxygen gas in the laboratory are given below. Write balanced chemical equation. So you have to write the balanced chemical equations. You are familiar with those. First one, heating potassium permanganate. That is KMnO4. That will give rise to K2MnO4, potassium manganate. Then manganese dioxide, MnO2. And oxygen O2. So to balance these, we need to have a 2 in front. 2 potassium, 2 manganese, 8 oxygen. So 4 and 4, 8 oxygens. Now that is a balanced equation. Then heating potassium nitrate. Potassium nitrate is KNO3. When you heat that, you get potassium nitride KNO2 plus you get oxygen. So to balance this, we put a 2 here and a 2 there. So 2 potassium, 2 nitrogens and 6 oxygen. So 2, 4 plus 2, 6 oxygens. That is the balanced equation. Then here we have heating potassium chlorate. What is potassium chlorate? KClO3. So when you heat that, you get potassium chloride, KCl plus O2. Here you have 3 oxygens, here you have 2 oxygens. Again, least common multiple, we need to have 6 oxygen atoms. So we put a 3 there to get 6 and a 2 here to get 6. But now you can see 2 potassium, 1 and 2 chlorines. So to balance that, we put a 2 there as well. So then the next one. Decomposition of hydrogen peroxide. That is also familiar to you all. Hydrogen peroxide, H2O2. When it decomposes, H2O and O2 gas are formed. Again, to balance, 2 hydrogens, 2 oxygen, 3 oxygen. To balance that, we put a 2 here and 2 there. 2, 4, 4 hydrogens. 2, 4 hydrogens. 2 into 2, 4 oxygen atoms. Here 2 oxygen and here 2 oxygen atoms. So now it is balanced. Is that okay, students? So those are the reactions, common reactions that are used in the laboratory to produce or collect oxygen gas. 2 potassium permanganate giving rise to 2 potassium manganate, manganese dioxide and oxygen. 2 potassium nitrate giving potassium nitride, 2 potassium nitride and oxygen gas. Then 2 potassium chlorate giving rise to 2 potassium chloride and 3 oxygen gas. 2 hydrogen peroxide gives rise to 2 water molecules and oxygen gas. So you all have to remember all these equations and you need to write the balanced chemical equation, students. If you forget the balancing, you can do that. But you should know the products of all these reactions. Is that clear to you all? So with that, I will move on to the next one. Extra question 20. Blast furnace is used to extract iron from its ore. Briefly state the reactions that occur during the extraction of iron. Write the balanced chemical equations. So here you have to briefly state the reactions and write the balanced equations as well. So can you all remember those? The raw materials, hematite, coke and limestone. First, what is the reaction? Coke burns in air. So here we can say coke burns in air. That is, coke is carbon plus oxygen CO2 gives rise to carbon dioxide. Then what happens? Carbon dioxide reacts with coke. So again, carbon dioxide plus carbon, that is coke, gives rise to carbon monoxide. That is also balanced. You can have the carbon first and carbon dioxide after. That is also okay. So both of them react and form carbon monoxide. Then what happens? Carbon monoxide reduces iron from its ore. What is the iron ore? You can remember it is Fe2O3 plus carbon monoxide gives rise to Fe plus carbon dioxide. So here, since there are 3 oxygens, we need 3 carbon monoxide and that will produce 3 CO2. To balance iron, we need to have 2 iron there. So Fe2O3 plus 3 CO gives rise to 2 Fe plus 3 CO2. That is the reduction of iron from its ore. Thereafter, what happens? There are the impurities and the limestone. Limestone decomposes. How does that happen? Limestone decomposes. So they have told us to write, briefly give the steps. So limestone decomposes. What happens there? Calcium carbonate, when you heat, decomposes and forms calcium oxide and carbon dioxide. From this also, a part of carbon dioxide can react with carbon coke, forming carbon monoxide. But we need this calcium oxide. What happens there? It reacts with the impurities present in hematite. So here, calcium oxide reacts with the impurities present in hematite, forming slag. So there are 2 reactions. What are the impurities? Calcium oxide first. Calcium oxide reacts with impurities. One is alumina, Al2O3, aluminium oxide. That will give rise to calcium aluminate, Al2O4. CaAl2O4. You can remember this is a combination reaction. So you just add all the atoms. So that's why Al2 and O4. Then we have calcium oxide plus silica, SiO2, silicon dioxide. That will give rise to CaSiO3. Calcium silicate, calcium aluminate, calcium silicate. Both of them together is what we call as slag. These two together is slag. Is that okay, students? So we have briefly explained the steps and we have written down the balance equations. Coke burns in air forming carbon dioxide, carbon plus O2, CO2. Then carbon dioxide reacts with coke again, CO2 plus carbon, carbon monoxide. 2 carbon monoxide are produced. Then carbon monoxide reduces iron from its O. That is the reducing agent or the reductant. Fe2O3 plus 3CO gives rise to 2Fe plus 3CO2. Then we have the reaction where limestone decomposes. Calcium carbonate becomes calcium oxide and carbon dioxide. Calcium oxide reacts with the impurities present in hematite forming slag. What are the impurities? Aluminium oxide or alumina, silicon dioxide or silica. So calcium oxide and alumina forms calcium aluminate. Calcium oxide and silica forms calcium silicate. Both together is known as slag. So students, you all have to remember all these reactions that take place inside the blast furnace. You should know to write the balanced chemical equations. Sometimes they can ask you like this, but mostly they specifically ask. Let's say how carbon monoxide reduces iron from its O, or how slag is formed. So if you know all the reactions, you can easily select and write the relevant equation for the question they ask you. So, but you have to know all the reactions given there. So with that, students, I will move on to the next question. Extra question 21. Diagram of a blast furnace. So there a diagram is given. A blast furnace used to extract iron is shown below. Label the parts A to H. So first we will look at the parts of the blast furnace. You can see A is what? They have shown the inward arrow. So there we mix limestone, hematite and coke finely powdered and fed into the blast furnace. Then B is where the waste gases are taken out. And C, here you can see fire brick wall to withstand the high temperature. So here I told you all students, D is the hot air blast. We pass hot air into that. Then E. E actually we will see E. Now it actually points to this outlet. So it is the slag being taken out. Then here you can see F. F is pointing to this one. So that is going to be the molten iron. And thereafter you can see here students, G goes there. So G actually points to the slag above it. You can remember that. Molten iron is below, slag is above that. Then we have this again. So I and D both are hot air blast, and here we have H. So I told you all E that is above is usually the slag out. So H is below that, that's going to be the molten iron out. So those are the parts of the diagram. Now we will have to label them. So then I will label the parts now. So A is the mixture of raw materials. You can even write the raw materials if you want. And then B, waste gases. Then C, you can see fire brick wall. Fire brick wall. Then D, you can see hot air blast. Then E, as I told y'all, slag out. F is pointing down, so it is molten iron. Then you can see G is the above layer, that is slag. And also the last one, H, is again the iron out. Iron out. So although they have given I, you can see both I and D, they are both hot air blast. So you can remember that. So these are the parts of the blast furnace that is used to extract iron. From the top, mixture of raw materials are fed. Then waste gases are removed from B. Fire brick wall is the wall. Then we have the hot air blast. Hot air blast is D. Then slag out is E. Molten iron. Molten iron is there at the bottom. Then slag is above that. And iron out is the bottom opening. So I am sure you also can label all these parts correctly, students. So with that, I will move on to the next question. Extra question 22. Write the metals suitable for the reactions given below. Write balanced chemical equation. State the type of reaction. So the first one. Metal X darts on the surface of water and reacts violently to produce a basic solution and liberates hydrogen gas. We have done this activity. What is the metal? Sodium reacts violently with water, darts on the surface, makes a hissing sound and also produces sodium hydroxide, that is a basic solution, and liberates hydrogen gas. So since we have identified sodium as X, we will write the equation sodium plus water will give rise to NaOH plus H2. So to balance, now you are familiar with the reaction, we need to have 2 here and 2 there, and also we will need to have 2 there. So 2 sodium, 2 4 hydrogens, 2 4 hydrogens, 2 oxygens and 2 oxygens. What type of a reaction is this? Sodium displaces hydrogen from water. So it is a single displacement reaction. Single displacement reaction. Single displacement reaction. Then we have the second one. Metal M does not react with cold water or hot water, but reacts with steam to produce the metal oxide with a chemical formula of M3O4. You all know these, students. Both zinc, iron, they don't react with cold water or hot water. They react with the steam. But out of those two, iron is the one that forms this type of oxide, Fe3O4. So this has to be iron. Fe plus H2O gives rise to Fe3O4 plus H2 gas. With steam to produce the metal oxide with a chemical formula M3O4, but at the same time hydrogen is also evolved. So if you are to balance this, now you need 4 oxygen. So 4 here, 4 hydrogen, and to balance iron it has to be 3. So 3 Fe plus 4 H2O gives rise to Fe3O4 plus 4 H2. So those are the balanced equations. We have identified the metals. I am sure you all also identified them and wrote the correct balanced chemical equations. With that, we'll move on to the next slide. So then next one. Metal A displaces metal B from the metal sulfate solution, that is blue in color. So you are familiar with that also, students. What is the blue color sulfate solution? Copper sulfate. And copper sulfate can be displaced by what? Normally we use zinc. Even if you put magnesium, that also can displace copper. anything that is above copper in the activity series, but it shouldn't be a highly reactive metal. So usually we use either magnesium, aluminium or zinc, and most common ones are magnesium and zinc. So you can write the reaction with any of the metals, because in the question you can remember, students, they said suitable metal. So you can write it with either magnesium or zinc. I will write it with magnesium plus copper sulfate will give rise to magnesium sulfate plus copper. So what is this reaction? Magnesium displaces copper, forming magnesium sulfate. So it's going to be a single displacement reaction. Single displacement reaction. Is that clear, students? If you want, you can write with zinc also. Then you will get zinc sulfate and copper there. That is also a single displacement reaction. So then, you need to arrange the metals X, M, A and B in increasing order of reactivity. So what are the metals we identified? Here I have taken magnesium, then we have copper, and in the previous slide, if you remember, sodium and iron. So we have sodium, iron. Out of all these, arrange the metals in increasing order of reactivity. So what is the metal with the highest reactivity? Sodium. Then the next one, magnesium, iron and copper has the lowest reactivity. So we need to start with copper, then we have iron, then we have magnesium and we have sodium. Now if you had taken zinc there, then what happens? That is also less reactive than magnesium. So you need to arrange them this way. Is that clear, students? Activity series, when you start from the top, at the top it is the highly reactive ones, it is the descending order of reactivity, decreasing order of reactivity. So you can remember that. But here the question says, arrange the metals X, M, A and B in increasing order of reactivity. So since they have said X, M, A and B, we might need to write that order as well. So here, if from our observation, metal A displaces. So A is magnesium and B is copper, whereas in the previous slide, if you can see, X is sodium and M is iron. So here we have X sodium and M iron. So in this, you can either write this order or you can write it as, because they have said X, M, A and B, we will have to, or we can write it as B, then iron is M, then we have magnesium A and sodium X. So B, M, A, X, or copper, iron, magnesium and sodium. Because in this question, they have not specified the order. If they say using the symbols given, you have to write this answer. If they tell you use the true symbols of the elements, you have to stick to this method. But since they have not mentioned anything like that there, we can give any of the two symbols, the true symbol or the letter given to you. Is that clear, students? So that is the order of reactivity. Again, to check, here you can see copper is B. Then M is iron, magnesium is A and sodium is X. So you can arrange them like that. So okay, students. So with those questions, I'm going to end this chapter, and in the next chapter also, I will discuss some more extra questions with you.